So let me give you some examples of type 2. So one on Linux, or on Windows that I use a lot, is Oracle VirtualBox. And it's a free VM environment you can use on Windows, Linux, Mac, and Solaris. And what you do is I can create a VM image on my Windows machine. And then the idea is you can export it. Exporting from VirtualBox to KVM sometimes has some problems. There's a sort of set of standards about how to represent virtual disk images. One's OVF. My personal experience is you often have to use a Linux utility to kind of convert it into something KVM can ingest. It's not really straightforward. So one problem I see today is that it's not straightforward to take a VM image made in one system and convert it to another. It's possible, but it's pretty janky to do it. So here's a screenshot from VirtualBox on my own computer here. So you can see I can create a VM with 768 meg. I've got, I think, 1 or 2 processor cores. So I can bring it up pretty quickly and actually load a DVD and start playing in the operating system. I haven't rooted my own OS, which is nice. Some other type 2 examples are VMware Workstation. So it's not VMware ESX. If you hear about VMware, there's 2 kind of styles. One's ESX, that's like bare metal VM. VMware Workstation runs on a computer as an application. They're different, okay? Parallels for the Mac. So you can use this to run Windows on a Mac. It's commercial software. It works okay, but we found that it's kind of slow. So we tried to have, for Nice, to have Mac laptops, and we had a Windows need for some of the applications. We tried to run Parallels, and it just was too slow. So it works okay, but it's not really fast. It's my own personal experience. I'm using KVM and OpenVZ for 2 different projects, my own personal experience. One is for Nice, or the Nice Hub. It's a cyber infrastructure based on Hub 0. And we're using OpenVZ as a virtual container or jail in which to run applications that interface with the user through a VNC window on a web page. And we're also using an OpenNebula cluster to run parallel applications. So for that, I've got basically a pile of computers in my lab. We've got OpenNebula running on them. And I'm using it for a few things. One is distributed rendering using Maya. So I can actually set up a batch render farm, and it's running Linux with Maya on it. The other one is OpenSea's building simulation for Nice. And so OpenSea's is a simulation that can either run in serial or parallel mode that basically simulates the response of a building structure to forces. So if I want to see how will this building shake if there's an earthquake, you can simulate that in OpenSea's. So I've run a parallel version that uses parallel solvers and MPI both in Windows and Linux underneath OpenNebula. It's worked pretty well. And so I'm running that on my cluster and OpenNebula, and also we've tried it with FutureGrid too as well, working with Gregor to get FutureGrid working with this. So the choice that you use really depends on the type of application and users want to run and the environment in which it's going to run. So let me give you an example of the use of OpenVZ. So for the Nice Hub, it's a cyber infrastructure we operate. If you want to try this, you can actually go to nice.org, register for an account, and do the things I'm going to show you, except for the workspace. You can run applications. But I'd recommend you try it out if you want to see what it's like. So in the Nice Hub, we can actually use Hub 0. Users log in. They can go and run tools in the Nice Hub. And so one of the environments we create is basically an OpenVZ container, which we can run Linux applications, X Windows applications. This is an example of software as a service. I'll talk about it a little bit later. So what we can do then is we can run Linux applications, set them up as a tool inside the Nice Hub. So when users want to run OpenSea's laboratory, for example, they can just go to this, start it up. It opens an OpenVZ container, connects a connection from through VNC from the server OpenVZ container to the user's web interface, start the application up, and just fill the screen. And that's how it works. So it works pretty well. I'll say, too, that we also have the ability to run Windows applications, and we use, I think we use Parallels for that. So we can actually run Windows and Linux applications through the Nice Hub. So there's a few other mechanisms in Linux that you might come across that I'm not going to go into detail about, but I just want to let you know about them. One's libvirt and virt.io. So if I have a Linux system running Xen, or I may want to run KVM, libvirt is an attempt to create a veneer layer over those 2 different systems. So you have one kind of API to talk to virtualization systems and one kind of command shell. I haven't tried it with Xen, but it works really well with KVM. Another one is brctl. So if you imagine, imagine if I had physical systems in my rack, I have to plug it into a network switch, right? You're familiar with that. If I have virtual machines running on a single server, I still need some kind of network switch. It's a virtual network switch. So on these systems, what's created on Linux is actually a virtual network switch with virtual Ethernet connections to each VM, and you can plug that into the interface of the system. So BRCTL is a set of utilities you use to control that. And another is C groups, which is a Linux feature for controlling the resource use of processes, and also network virtualization. So there's some underlying technologies on Linux that are used to make this work. Let me say that what I found in my experience is network control is a constant problem because it's, you know, the VM part is pretty well thought out. Making the networking work really seamlessly and smoothly is not as well thought out. And some of the problems you come across are setting up the virtual network switches. If you do something like VLAN tagging, it's a lot of work to make it work. Because if you try to VLAN, does everyone know what VLAN tagging is here? No, okay, let me explain. Yeah, some people do. So imagine you've got a network switch and you plug your computers into it at your own personal network space, okay? Now, you can give an IP address like 192.168.x.x. It's definitely your own personal private network space. Now, let's say that you and 3 other people in your lab want to create their own networks, and you only have one giant network switch, like a Force 10 network switch, and you don't want to see each other's traffic for whatever reason. So what you can do is create a virtual local area network, or a VLAN. So what you do is you tell the switch, everything that comes from my network, I want to have it a VLAN tag of A. Everything from my friend's network is going to be VLAN tag of B. So it ties the ports to this. It's kind of like being able to partition a network switch into little individual private network switches, okay? It's a really great technology. The problem is to configure switches, you have to log into the switch as an administrator and configure it. It's not so easy. So you can do VLAN tags. You can set up VLANs on Linux virtual switches, but it needs to talk to the physical switch. So you need to configure both ends and sort of make it work. It's not so easy. So there's a project called OpenFlow that actually I use involved in that's trying to make this easier to have sort of one control station that can push out configs to network switches. And they're working to try to simplify this and make it scalable. It's still a research project. So let's move up from virtualization. So we talked about virtualization on a system level. It's like, okay, I can do KVM, I can do Zen, I can do VirtualBox. Okay, I've got my system with my VMs on it. The next problem is how can you manage a collection of virtual machines on a single system? Let's say I want to scale up to like 30 virtual machines. Well, what if I want to actually scale up to like having 10 physical servers with 30 virtual machines each? That's 300 VMs. That's a lot of typing, right? That's a lot of work. So the problem is how do we manage a distributed network of computers, and how do we manage the network for this as well as the VMs? So this is a basis for one aspect of what's called cloud computing, which you heard about this morning. And this is called infrastructure as a service. So the technology used for infrastructure as a service is a basis for building virtual HPC clusters, which we'll talk about.